All right. So I will copy a question on the whiteboard. So whatever we learnt so far, we will attempt some questions on that.
Hmm.
Okay, which means we learned about QVB and BIL. I think the last question we did was all right. So this is the question. Try this. QV cross B. Okay. So magnetic field is inwards.
Hmm.
So you can write magnetic field as And we know when we do this, the charge is positive.
Correct. Hmm.
And if the charge is negative, we have to reverse it.
Hmm.
So think like vector. Velocity कहाँ पे है? Velocity is an x-axis, right?
X-axis.
So
तो
velocity
Z
is
में होना
I,
चाहिए मतलब.
but you have to write it.
Hmm.
Velocity is equal to v I. Tell me where is the difficulty?
नहीं, ये तो बहुत इजी था.
आंसर नहीं आया यार. I'm waiting. You have not said a word.
मैंने अभी बोला था, आवाज नहीं आई मेरी.
नहीं नहीं. You have to write it. Board
इसमें
is
कुछ
not a
लिखने
verbal
का है
exam.
नहीं मतलब.
नहीं है. This is a question from NCERT. इसमें लिखना है आपको. You have to give a reasoning. मैंने लिख दिए हैं तो ऊपर. This rule is also known to you.
Hmm.
That you have to move from V to B.
इसमें तो सीधा रूल लगा के आंसर
लगाओ,
होता है. इसमें
write
लिखूं
it.
क्या?
So I have written right. This is my force, and I have written the as per the direction, and then I am writing F is equal to Q V I cross BJ. ये क्रॉस प्रोडक्ट है. दिस इज द क्रॉस प्रोडक्ट.
Hmm.
What is the cross product of I into J? I cross J. I J K. If it's I cross J, you get a K. If it is J cross K, you get an I. If it is K cross I, you get a J. It moves
Hmm.
like this. So this is Q V B I cross J is equal to Q V B K. So I found out the direction of the force, Lorentz force, with the help of vector product knowledge. K means upward.
Hmm.
If the charge is changed to an electron, second part, if you change the charge to an electron, then the force will be minus Q, magnitude of, which means minus K, which means in the minus Z axis. So you can write
Hmm.
using the very basic knowledge of, right? So if this had been a multiple choice question, fine. But since you also have to write in board, it's very important that you
Hmm.
write, right? You cannot leave it to your mind. Okay? Okay. Please tell me the directions of the situations when the force is going to be minimum and maximum. That means no force and maximum force. What are those conditions? What are the conditions for maximum force experienced by a charge? And also tell me the conditions for zero force experienced by a charge. What happens? So assume the same question. What will you do different to create these situations of a maxima and a zero force?
मैक्सिमम फोर्स तो तब होता है जब वेलोसिटी की और मैग्नेटिक फील्ड की डायरेक्शन 90 डिग्री पे
लिख
होती
दो
है
when
परपेंडिकुलर।
theta is equal to 90 degree. आंसर करेक्ट है. ठीक है. अगला. Good answer. And what all will you do to make the force to be a zero force?
वेलोसिटी अगर जीरो कर दो।
Agreed? Agreed. So velocity is zero. That is one. What about a second situation?
मैग्नेटिक फील्ड भी जीरो कर दो चाहिए।
Then you're not having magnetism, then you're not studying magnetic force. I mean, you're saying magnetic field does not exist, right? I'm saying keep everything will exist,
अच्छा,
right? But if there is no magnetic field, yes, there is no magnetic force.
अगर थीटा जीरो कर दो।
तो parallel हो जाएगा.
हम्म
If it is parallel, that means the angle is sine of zero,
यस सर।
right? Which means you were saying that make V and B parallel.
यस सर।
Yes, agreed,
ठीक है।
right? Now the sign convention that you must know. Good answers. Drawing convention. So if you're seeing a vector being drawn like this on the right, you can see the diagram.
ओके।
This is a magnetic field from left to right. If you see a dot, right, the vector is coming towards you.
ओके।
If you see a cross, the vector is moving away from you inside the page. For example, in this question, you see cross. A cross will represent the vector going inside the page.
ओके।
Hence, the magnetic field is parallel to positive y-axis, and the charged particle is moving along. Right? So it's parallel to positive y-axis, which means inwards. This is your positive y-axis.
ओके।
Be very careful on noticing the cross and the dot to represent the magnetic field. Magnetic field is outside. If you are given a dot, which means the out of the page towards you. The
अंडरस्टूड।
impact is if had it been outside, moving out towards you, you would use minus j here. Got it?
यस सर।
Okay. So vectorally also you should have clarity on magnetic field. Velocity is okay because we've done kinematics. So we understand the direction convention for velocity. But the direction convention for the magnetic field also should be understood.
अंडरस्टूड।
Got it?
यस सर।
All right. Let's try some questions for you. Most of the confusion happens because of direction. So when you're doing questions where you have a formula, but it involves a lot of vectors like vector product, dot product. So you don't end understanding it after you have understood how to calculate the magnitude, but also continue to learn it till you have mastered the direction of the.
Okay, sir.
All right. So one more question for you. I have a lot of cough today, so just bear with me.
It's okay.
The other is you should have a very sharp eye towards the diagrams. Read it carefully, see the diagrams, understand the diagram pretty well.
Okay.
So this is electric field given to you. These are dots. What do dots represent? The
Coming
magnetic
out.
field is coming outwards. Correct. So now first draw the charge. Show the electric field force on the charge. It's a positive charge. What will happen to a positive charge moving with a velocity? The positive particle is released from rest,
Hmm.
which means its initial velocity is zero. And once it is a part of the electric field, which is moving upwards. The electric field direction is given, right? This is the electric field.
Yes, sir.
If you keep a positive charge here, what direction will it move in? It will go upwards. The
Correct.
electric field start from positive to negative, right? Away means drop in potential. So the charge will now start going upward. So the positive charge will experience upward force due to electric field.
Hmm.
So it will start going like this. And therefore
Correct.
it will acquire a velocity.
Hmm.
But as soon as it acquires a velocity, you know you also have a magnetic field present in this area.
Correct.
So as soon as you acquire a velocity, you will be subjected now to a magnetic field force also. So magnetic field force B is outward, outside the page. It's a positive charge going with a velocity v at any instant. Say this is instantaneous, because when you get the force from the charge due to the when you get the force on the charge due to electric field, what's your acceleration going to be? So you will accelerate also continuously, right?
Correct.
Because of the influence of electric field. So you are now, assume your situation is V at any instant. You know the direction of B, you know the direction is V. Now you have to find the direction of force using your vector product knowledge. So you're moving from V to B. So the screw will open outwards. So the force is going to be in this direction.
Correct.
And since your velocity is constantly changing and the force is perpendicular to the velocity, finally you will get a arc-shaped structure. We will study why, but at least this is clear that it will start moving rightwards. It will continuously go upwards with a new velocity, and therefore the magnitude of force will continue to increase on it because it is accelerating. The velocity is going up. So therefore this velocity is increasing continuously. This velocity is increasing, so therefore the force will also increase, and therefore it will continue to be rightwards.
Okay.
Understood?
Hmm.
So sometimes you get tricky questions where you have both the electric field and the magnetic field present. You have to see what value is being brought by electric field and what value is being brought by the magnetic field. You have to decide the strategy. Sometimes they may be working against each other. What was the function of electric field here? To provide velocity. If
Hmm.
there was no electric field and you leave a charge at rest, there is no magnetic force on that.
Correct.
Make sense?
Hmm.
All right. So
Agreed.
let me just bring in. Okay. I'm just adding the NCERT file to the board. I think these very small exercises and conceptual questions, very useful.
Hmm.
All right. So let's look into. It's still uploading. Okay. Yes. We had done till magnetic force on current carrying conductor, BIL.
Hmm.
We did a derivation. We did this also. All right. So now we will do the motion in a magnetic field. What exactly goes on in a magnetic field? Okay, just look into this diagram. You can see the cross, which means the magnetic field is inside,
Okay.
right? And you can see the. So we are going into the details when charge moving with a velocity v in a magnetic field, what exactly goes on? Okay, so first thing you have to understand is that if there is a so one thing is very clear if you notice, okay, and I will just put it on. So you know now that the force being experienced by a charge is being given by as a vector q v cross b. Okay, and if you draw a diagram, this is what you find, that they exist as a triad, which means if you have a V here and a B here, and you do V cross B, for example, on a positive charge, the force is
सर आपकी
perpendicular to.
आवाज चली गई.
Okay. Is it coming now?
हाँ अब आ रही है.
Okay. So you have a velocity and magnetic field, and the force is perpendicular to both.
Hmm.
Right. So this is so force is perpendicular to velocity, and force is also perpendicular to B.
Okay.
Now, if you go back to chapter 3 of dynamics, Newton's law, if you apply a force on a body,
Hmm.
it results in an acceleration.
Okay.
So you have a mass, you apply a force, you will get an acceleration.
Hmm.
And since you're accelerating the body, and supposingly the body covers a distance s, the work done is given by the dot product of force and the dot product of the displacement,
Hmm.
which means the angle between the force and displacement matters,
And yes, sir. Agreed.
right? So if you are applying a force in which force is like this and displacement is also like this, that means your work done will be F S cos 0
Okay.
because they're parallel.
Hmm.
All
Agreed.
right. Dot product. The work done is calculated by dot product. Okay. Now I take that this is my mass, this is my force, and the body moves slightly by an amount s. And the angle between the force and the displacement is theta. So my work done is F S cos theta. Okay.
Okay.
Now let me put theta is equal to 90 degree, which means this is my body. I'm applying a force. This is the displacement. What is the work done? Which means if force and displacement are perpendicular to each other,
Hmm.
no work is done.
Okay.
If no work is done, then you are not transferring the work done to the body, and therefore the body even does not accelerate. Example, you have a man who who's carrying 50 kg on his head, and he carries this 50 kg on the ground to a distance of 100 meters. The direction of 50 kg is where? Weight. And the displacement is in x-axis. The work done by the man to carry 50 kg is 0
Okay.
because they are perpendicular to each other. If you
Hmm.
don't do work on a body, if you don't do work on the body, then you cannot accelerate the body or decelerate the body.
Correct.
Because when you do the work, if this is a body at rest, you work on it, you provide it some velocity and acceleration, it gains a kinetic energy.
Hmm.
If you don't work on the body, you cannot change its kinetic energy. It'll remain what it is.
Correct.
If it was 0, it will remain 0. If it was 5 joules, it will remain 5 joules. So I have a body which is moving like this, 5 meter per second in this direction, the displacement, and the force is in this direction.
Hmm.
Throughout the motion, this force will not be able to change the velocity in this direction because they're at right angles. So we will say this force is not doing any work.
Agreed.
Only if you have angle which is less than 90 degree, some work will be done.
Hmm.
Why are we studying this? Because if you notice the situation of an electric field where you have a situation like this, you have, for example, I've already drawn the trajectory of the charge. Let us see what happens when you project a. So let's assume these dots are the magnetic field, right? The dots on the paper.
Okay.
You project a charge with v velocity, and you know the net force is going to be perpendicular to b, and the net force is also going to be perpendicular to v.
Hmm.
Right? So consider any instant where the velocity of the body was there in some direction, and magnetic field will always be perpendicular to it. The way this works is that wherever you calculate, for example, the charge is here,
Hmm.
and the velocity is in this direction, right? And the magnetic field is outward. The V cross B for this is going to be like this. This is your
Okay, sir.
magnetic field. Now, if you go back to class 11th, and we have not covered this as yet, in a uniform circular motion, in a uniform circular motion, the velocity is always tangent to the centripetal force.
Hmm.
Always. So if you consider this point, the velocity is downward, but the centripetal force is towards the center. Yeah. So if you project a charge in a magnetic field, the net force which is experienced by the charge is always perpendicular to B and V. And this particular aspect is same as uniform circular motion. So if you actually project a charge in a magnetic field, you will find that at any point the force is perpendicular to V, which is only possible in the case of a circle. So if you project a charge in a uniform magnetic field, then you will see the charge traversing a circular motion. This Q V cross B force
Okay.
is directed towards the center of the circle and is the source of the centripetal force.
Okay.
The formula for centripetal force is this. A centripetal force means a force that is directed towards the center of a circle.
Understood.
Okay. Let's get into the details now. Okay. So let's read this part. And I'll just. So in this, the motion of a charge, the magnetic force is perpendicular to the velocity of the body. So no work is done and no change in magnitude of velocity is produced. That means there is absolutely no change in the velocity. One of the key characteristics of a uniform circular motion, and the word uniformity, is that if the magnitude of velocity was 5, it will always remain 5. Wherever you may go. The only thing is the velocity vector will be different.
ठीक है.
Which means if you consider velocity vector at the top, you can write this velocity vector as 5i. And if you know the velocity vector here, this is minus 5j. If you see the velocity vector here, it is minus 5i. If you see the velocity vector here, you can split it into two parts if you know this angle theta. So this is also 5. And you can split this velocity vector into two parts. This is the radius of the circle.
Okay.
The velocity vector and the radius are always perpendicular in a uniform circle. The velocity vector and the radius vector are, this is the radius vector. Both are rotating. Take this position. Radial forces towards the center. No work is being done because the force is perpendicular to the displacement. You cannot produce anything. If you have velocity and the force as perpendicular, no work is done. Very similar to when force and displacement are 0.
Yes, sir.
Right? So if you enter a magnetic field and you're a charge and you enter the magnetic field and the magnetic field is perpendicular to the velocity, right? So we have taken all perpendicular situations in our scenario. We have taken that the force is proportional, force is perpendicular to V, and the projection which you have done in the magnetic field is perpendicular to V. Your velocity is perpendicular to B. So you're entering the magnetic field with a certain direction. So your entry to the magnetic field is also very important, how you enter. So if you have these magnetic fields, Okay, these are your magnetic field lines. And we have been assuming that this will be a circle. Yes, we have been assuming, but your entry has to be at right angles to the magnetic field. So this is a magnetic field you can see, and enter in it at a right angle. Don't enter it like this.
Okay.
Because if you enter it like this, of course, you will have one component which is again perpendicular. The other component will be in this direction.
Hmm.
This particular component, which is perpendicular to the magnetic field, will result in circular motion, which is what we are studying. So when we say that the charge is exhibiting circular motion, right, we are saying that the force is Q V cross B. We are studying a situation where velocity, which is being considered for this particular scenario of uniform circular motion, is perpendicular to B. That means theta is
90 degree.
if theta changes, you will see certain different scenario. Something else will start happening. So if you see a question in which you have a charge being projected in a magnetic field, and they say it's a uniform circular motion only, then you're very clear theta is 90. And you can use this also, which means you will write Q V B sine 90 is equal to mv square by r. V will get cancelled. So QB is equal to mv by r. And you can find the radius of the revolution, which will not change. The mass
Yes,
of the charge will not change. The velocity you cannot change unless you have a force which makes an angle with velocity. And you have to do work to change the velocity. If there is no work being done, no velocity change. The magnitude of charge is unchanged, and the magnetic field is also uniform. It is fixed. So you will get a fixed radius. If you change the mass of the particle, double it, the radius will double. If you decrease the charge by half, the radius will double. If you suddenly change the magnetic field to double, the radius will become half. So you can see, you can control the radius of revolution by 4 methods. One, mass. You cannot change the mass of a charge which is in circular motion suddenly, right? You have velocity. That also is decided when you entered. You can not change the charge on the particle if it is undergoing a revolution suddenly. The only thing control you have is B. Maybe you have a source of magnetic field which you can change to double, half, so you can control the radius. Once you have already projected, how can you change this? How can you change
possible.
this? General scenario. But broadly, if you change the magnetic field, you can change the value of the radius of revolution. Okay. Since you're in a circular motion, since you're on a uniform circular motion, and therefore you will have a time period, which means how much time do you take to cover the whole circle? Time period. Okay, so velocity is equal to distance upon time. So this is one revolution. Circumference. The time taken to complete one circular motion is time period. Time period. The time required to cover one full circle. Now we found the radius. We already know the velocity. We are saying let's find out the time period. How much time will this charge take to complete one complete full circle, revolution? You already know the velocity, you found the radius.
Yes,
Put the
sir.
values, you will get the answer in seconds.
Okay.
If you do reverse of this, you will get the frequency of revolution, which is how many revolutions per second
Hmm.
in hertz. This is frequency of revolution. In t seconds, you have one revolution.
Correct.
T is the time period, right? So in 1 second, you will have so many revolutions. And so many revolutions per second are known as frequency
Hmm.
in hertz. So earlier we were just considering these questions that the force is perpendicular to velocity and the magnetic field, and we were learning how to apply the concept of vector product to find the direction of the force. Now we realize this force has a unique characteristic that it can result in a circular motion because it is always perpendicular to the velocity.
Hmm.
And therefore we started applying the concept of circular motion, uniform circular motion, with an assumption that the angle between velocity and b is always 90 degrees.
Understood.
All right. So before we move to the next topic of, okay, let's see. So let's solve one question on this. Okay. All right. Try 4.3. 4.3. You can try it on the right hand side or left hand side, wherever you want to.
Hmm. सर मुझे फोटो दिख नहीं रही.
It's an inserted file, usually, NCRT. I've
मेरे को
pushed
तो सिर्फ एक ही पेज दिख रहा है.
4.3. That is the one. The question is on that page only.
मेरे को तो इंट्रोडक्शन पेज दिख रहा है बस.
Achha, see if you can move forward on that.
नहीं, अलाउड नहीं है मुझे.
Okay, let me just try and paste it then. I'm pasting it separately then.
यस सर.
Okay, so that it's easy for you to. Got it?
यस सर.
Okay. frequency.
Yes, sir.
Second part is frequency, right?
Hmm.
ठीक है. Okay, ठीक है. You know the time period, and if you inverse the time period, you will get your frequency. Perfect. ठीक है. I think forget the calculation. ठीक है. Just do
ठीक
1
है.
by t and write hertz. No need.
Okay.
Point is, have you understood what you're doing?
Yes, sir.
You've understood, right? It's a full revolution calculation being done. That's all.
Hmm.
Perfect. If you understand, leave it. Just see the
ठीक है.
next one. You should get friendly with these concepts. That's all.
Hmm.
Okay, what is the next part? You have to calculate the energy,
Half mv square.
half mv square, right? Because that is the initial velocity energy with which it was projected. It will not undergo any change in velocity. Cannot, because there is no source. If force is perpendicular to velocity, no work is possible. If you don't do work on the body, you cannot change its kinetic energy.
Correct.
Clear? Half mv square.
Yes.
Next to. What are the signs? First thing you will see is what is the direction of the magnetic field, inward or outward. Associate a vector with that, j, k, minus k, or whatever, based on your knowledge of dot and cross.
Cross.
Right? A dot represents out of the page. Cross represents inside the page.
Page.
So you have three charges. You have to tell the sign.
Hmm.
So apply QVB thrice on three situations.
Yes, sir.
See where it is left from your vector product knowledge. Left, undeviated, right. These are the three directions you're getting.
ए में नेगेटिव होगी और बी में इस तरह से- नहीं, ए में पॉजिटिव होगी, बी में न्यूट्रल और सी में नेगेटिव। हेलो।
I'm saying you have to write it mathematically,
ओके।
which means you have to show the vector product. I have assumed the magnetic field which is coming out to be minus J.
ओके।
If you consider it plus J, your answer will reverse. But when
अंडरस्टूड।
you're given a question in board examination, you have to explain why.
ओके।
This is not an MCQ. This is a explanation of direction of vector. So this observation is correct, and same is true for the C also.
यस।
You have to have very good grip on vector product. Next, fifth. Okay, we will discuss vector product. I have understood. So in this question, you have to compare the velocities.
Hmm.
But you know the radius. Whose radius is smaller?
Yes, sir.
So that you know. RB is less than RA. You should first write the formula of radius. I will start from here to make a comparison.
एक की ज्यादा वेलोसिटी होगी। सर आप म्यूट हो।
Everything else is identical.
रेडियस के डायरेक्टली प्रोपोर्शनल है तो
Radius के yes.
इसलिए
So
वेलोसिटी ज्यादा होगी।
small yes. Next. So you should have a detailed sense. If we change one of the variables, what is the impact on others?
हम्म।
No change in time period. Time
Yes, sir.
period is independent of velocity, right? So
Correct.
answer A.
Hmm.
ठीक है ना?
Yes, sir.
Next. Reasoning and assertion.
C.
Okay. So when a is right angle, the radius of the is directly proportional. C. Correct है. Good answer.
ठीक है.
They made a fool out of you by giving you another concept as a reason.
Yes, sir. वही मेरे को कंफ्यूजन हो रही थी कि करेक्ट है कि
हाँ,
गलत था.
बहुत बढ़िया. नहीं नहीं, अपने go with your logic because your logic is getting stronger now.
Yes, sir.
So these small questions will build a very strong last question.
Okay, sir.
Alpha particle is 2 plus. Just remember that.
Yes, sir.
Alpha.
Sir, A part.
Correct answer है. Any questions from your side?
नहीं, sir.
Hope this is giving you clarity, more and more clarity.
Correct.
So I'm not doing another topic with you. I think you've practiced, you understand the concept pretty well, and then we will move to the next topic after this. So let's meet in the evening for our maths class.
Okay, sir.